Hello. I think there's a slight time warp going on here, but for those who don't know me, I am Nicole Pierce-Turner. I am the host of That Engineering Chat, which is a podcast show that we're delighted to be joining with EDS Reconnect and EDS and Subcon this year. And we are really excited to be doing this with EDS Reconnect, a live interview. And we thought we've got to talk to someone that's really gonna, keep you guys interested in what we're talking about here and get you excited, get your juices flowing. So we thought, let's talk to someone, Sam Rogers. You check him there, Sam.
Yeah.
Rogers from Gravity Industries. Welcome, Sam.
Thank you very much.
How are you?
Very good. Yes, we've been out testing, but now I'm back in this lovely white room.
Okay.
But yeah, very good to be with you.
So you're from Gravity Industries, Sam. It's the additive design lead and one of 3 jet suit pilots at the British engineering company Gravity Industries. Is that right?
Yes, that's right. So Gravity builds the jet suit, which is essentially a 5 turbojet engine powered suit that you put on one on each arm and a backpack, and that allows you to take off and fly, kind of like Peter Pan. But it looks a lot cooler than Peter Pan. Yeah, so that's what we do. I'm the design lead there. So everything that you kind of put on your body and wear, I design with the team at Gravity. And over the few years of being involved with this, I learned to fly as well. So when we go and do events, I'll go and actually, pilot the suit. And we have a few team members who can go around to these events and actually do the flights as well. So it's quite cool that when we do fly, you've not only kind of designed it, but you can also fix it if something goes wrong because we built the thing. That's
brilliant. I mean, a jet suit pilot, that's not only does that sound really exciting, but it's literally like a real life rocket man. You're literally, I mean, you explain what it looks like. It's an engine strap to each arm doesn't do it justice. I mean, can you elaborate a bit more? I mean, you've sort of explained it a bit, but literally when you design it, how big is it?
Well, the best thing is I do I show you pictures of Instagram because I've not got a PowerPoint today. So there you go. This is what it is. If you imagine a backpack, 2 arm mounts, and it allows you to fly. Lots of people have seen this on social media, but essentially 5 turbojet engines. So there's one in the backpack, and then 1 in each arm, 2 in each arm, and that allows you to take off and fly. So it's just creating enough thrust that you can actually throw enough air downwards that it counteracts your weight and you're able to take off.
And there's also a helmet. Does the helmet, tell us about what does the helmet do to help with the flight? Is there data in there or anything? What does that do?
We've tried it a lot. We've tried heads-up displays. So when you see Iron Man or something, you have that lovely, cool-looking heads-up display, which is designed by an excellent graphic designs team, with like horizon level and destination and all that kind of stuff. And we've actually tried all of that. And really, what you want to be focusing on doing is flying, rather than looking at all of these crazy data, and calling people and all that stuff. It's just kind of confusing. So we've tried loads of different things, like looking at your speed, your location, a map, all this stuff. But really, all you need is something like a phone-sized thing here that you can look down at. You know where you are. But the only thing we really now use the heads-up display for is a little arrow. And imagine like a video game, you've got that arrow above the character and it points to where you're supposed to be going. That's the best thing. It just points to where you need to go and you follow that arrow. So the best thing with that is to keep it simple and not clutter up your visual field.
So okay, so take me back to the beginning, please. When did you decide that this is what you were going to do? You were going to create and make and design jet suit pilots. Like, where did this come from? Is this always a dream? Is this something you'd thought about as a little boy? Was it something you did at college? How did it all begin?
Well, yeah, I didn't just decide I wanted to do it. I didn't even know this role or doing any of this would exist really. But when I was very young, my granddad taught me to make gunpowder. As you do, when I was about 7 years old, he taught me to make gunpowder, which is probably a terrible decision. But I then started making fireworks with him, He taught me how to mix, all the different recipes together that make different coloured fireworks. So I burnt my fingers a lot, but luckily I was kind of allowed to experiment with building these fireworks and blowing stuff up and things going wrong, going right, and then kind of gaining a tremendous respect for fire and high energy systems and things like that. So from there I went and built the kind of rockets rather than things that just go fizz and bang. I'd kind of build little rocket motors, fly model rockets. I built a lot of radio control planes and flew those, and I'd kind of design and build my own ones. And with all of those projects, I'd also do a lot of filming, and I kind of made my own camera equipment, like a steady cam and things like this. So all of the projects I did, whether it's little radio control planes or rockets and things, I would always film it or photograph it. And I just had this massive backlog of all these photos of these kind of fun things, lots of which had failed, lots of which had worked. Well, no, few of which had worked, lots of which had failed. And I just had photos of all of them. And so when it got to the point where I was like at school and university and stuff like that, when you could, I could just bring up these pictures of all these things I'd built. So I started working at a metal 3D printing company because I just had built all of these rockets and things, and I could just slide it over the table and say, I've built this stuff. I don't know if it's relevant, but I've done some things, and luckily they quite liked that. So I got into this metal 3D printing company. I learned about how to design for metal 3D printing. Most people don't even know metal 3D printing exists. I've got some bits here. You can make amazing things. This is an alloy called Inconel. This is part of a combustor for a jet turbine. But all of that is one part. Normally you'd have to machine it out of loads of little pieces and join them all together. But with metal printing, you can make these amazing alien-like shapes. So I learned to do that. And then from there, I got involved with, I kept kind of pushing rockets and saying, why don't we build rockets out of metal printed copper and things like this? And I managed to get involved with a few rocket companies through that. And then I happened to be out at a metal 3D printing company in Germany, where I was working on a rocket project, and it so happened that Richard Browning, the founder of Gravity, who had founded this a year or so earlier and started experimenting with this jet suit, was out there doing a demo flight with one of the early versions of this. And he was out there to explore what you can do with kind of 3D printing. And because at the time the suit was made of mostly kind of DIY store aluminium with holes drilled in it to make it light, and it was the very early stage kind of prototype. And he'd just started experimenting with 3D printing. So I happened to meet him there. We walked past this room, and I smelt the smell of the engines as we walked past. And I said, "Who's in there?" And the guy said, "Oh, it's the jetpack guy." And so I managed to convince him, "Come on, let's go in, let's go in." So we kind of barged in, and I saw these arm mounts on the table, and it was this amazing smell. I'd always wanted to own a little turbine like this that you get in these little radio control planes. At that age, it was kind of a dream thing. And I saw these on the table, and there's this amazing smell there. And then I managed to find out who it actually was in the crowd of people, and then kind of barged up and said, "Hello, I do all this 3D printing stuff and rockets." And we spoke about 3D printing and stuff you can make for a little while, exchanged contact details. And then a couple of weeks later, I was down in Salisbury, and we were experimenting with some 3D printed parts and actually talking about what we could do. So at that point, I'd got involved about a year and a bit after he founded it. And from there, we started experimenting with how can we actually advance the suits with 3D printing. And that's when we went down this whole trail of 3D printing the entire suit rather than making it out of aluminium and all this stuff. But I'll get some pictures up of that in a minute. I'll let you ask another question because I've rambled for long enough now.
I know, I love that. I mean, it's really interesting to find out how that all happened. I'm sure lots of people would love to hear about that. Describe for us your typical jet suit flight. I mean, you have to balance on your toes and reach optimal power, don't you? How long does it take most people to take their first flight? I mean, can I do it? Can I come along and whack them on, or is there a certain amount of finesse that's needed or experience?
Yeah. Anyone can do it, really. It's quite cool in the way that when you're training, it separates people from who are very spatial aware and capable of picking up new skills, and people who maybe have not done so much kind of physical stuff, and they just take a little longer to learn it. And it's not about being necessarily physically strong, it's just how often you throw yourself out there and like learn to surf. Like people who are really relaxed, like surfer duty attitude, can just relax into it and pick it up really quickly, because essentially you've got 3 thrust vectors, 1 on each arm and then 1 on your back. And as you throttle up, those things are producing more and more thrust, and you hold them out to your side and you don't take off until you point them downwards, because if you're pointing all the thrust downwards, you're going to go upwards. So if you can relax into that experience of 5 turbojet engines starting up on your body with, you know, flames coming out the nozzles, this amazing bah noise as if it was out of a film. And the first go is always about like acclimatizing and just realizing, holy crap, this is all going on around me and I'm wearing 5 jet engines. But after that, then as long as you relax into it and you don't become scared of it, scared of the forces on your body, and you just kind of go for it and really kind of overcorrect. If you put one arm out this way and feel that, whoa, I get blown over this way. So now I know what that feels like. So if I put one arm in front and one behind, I'm going to spin. So it's about just throwing yourself into it and trying to learn as much as possible how the system reacts when you point your arms in different directions. So if you're really spatially aware, you'll be brilliant at it. But everyone can have a go. And we've got a training rig at Goodwood and in a few other locations where people can just come for the day, put it on, and have a go at learning to fly, which is great because anyone can do it.
That sounds amazing. I'm not very spatially aware, but that sounds amazing. I would like to definitely give it a go, but I don't know how good I would be. I mean, you mentioned
it's not even about being spatially aware. It's just like it helps. But really, if you just throw yourself at it and you're willing to like have a good time and not kind of lock up and glaze over, like we have a few people who like they get overwhelmed by the experience. You kind of have to go, hello, is anybody in there? But once if you're present and just having a great time with it, usually you pick it up really quickly.
And what sort of power thrust are we talking? I mean, you mentioned there's 5 there. What sort of power are we talking from each jet engine to elevate a grown adult? And are there restrictions on? I mean, you know, is there a smallest size adult and a largest size adult, should we say, that can go in these? Is there any restrictions around that?
Yeah, we can fly most people really. If you're massively heavy, then we have a larger suit that we're building at the moment, which is focused around carrying a person with payload. For example, the paramedics mountain rescue that we're doing at the moment, they want to carry payload so they can fly up a mountain to someone who's injured themselves, land, stabilize that person with the necessary medical gear, and then they're stabilized such that they can then be lifted down the mountain. The key is getting to them quickly and providing medical assistance. So they need to be able to carry up that medical equipment with them. So that's why we're building this the heavier lift suit. But yeah, anyone can really come and have a go. And in terms of power, it's more thrust to weight ratio than most fighter jets really, but all you've got to do is lift a person's weight plus a bit more. So the normal suit would be about 140, 150 kilograms of thrust, and that's enough to lift a person and the equipment with some spare.
Goodness me. And how long is the flight possible for that sort of power? You know, I mean, I know it's obviously respective of sizes and all the things, but on your average person, how long is the flight? Because like when you're talking about going up mountains, I mean, that's phenomenal that you're able to do things like that, but how long can you go?
Well, most of the flights we do are quite short. Like when we're doing demos, it's seldom longer than a minute because you kind of fly around, you fly up to people, and then you land, stow the engines, and shake people's hands. But the flight time, depending on how you set it up, is kind of anywhere between 4 and 6 minutes, which doesn't sound very long, but all of the flights we've done, for example, up the mountain, we did a 4-minute flight up a mountain, and that 4-minute flight would normally have taken an hour and a half to walk. And we've done another one in 90 seconds that would have been about a 25-30 minute walk. So that's the difference in response time, especially for the paramedic stuff, where if you're bleeding out or something like that, we can get to you in a fraction of the time. That is really impressive, isn't it? That's a real life changer. But it's not something that you want to. It's not like you're going to put on a jet suit and fly across the Atlantic. It's it's far more comfortable sitting in a reclining seat and watching a film. You don't want to be there like with your helmet on, wiping flies as they go onto your goggles. You don't want to be wiping them off if it's raining and cold. You want to be sat in a lovely seat. So it's more for like short distance mobility over, especially terrain that you just can't pass quickly. Any records set? What's been the longest flight? To date? I don't know about the longest flight, but the speed record. So Richard broke the speed record at 85 miles an hour, 86 miles an hour, and that was down at Brighton alongside the pier. We flew out. So we had a few of us take off as a kind of escort. So if you imagine a pilot either side flying out, and then in the middle, Richard was flying with a leg wing, and the leg wing is essentially an inflatable ram air wing between your legs, kind of like what wingsuit skydivers wear when they do those crazy proximity flying flights. So what it means is you take off like this, and then as you get in more and more speed, you start to go horizontal into the airflow and use some of the aerodynamic lift, and it means you can actually go faster because you're pointing loads of that thrust backwards. So got to 85 miles an hour doing that for a Guinness World Record.
Wow.
But we don't normally fly that fast. Usually we fly, you know, quite kind of low and slow, and that's part of the safety approach that we have, is that there's no need to go high. You could fly up to 6,000 feet if you wanted, but there's just no point. For all the stuff you need to do, if you want to go across a boggy field and then a river and then sand dunes and then a boulder field, you probably need 3 or 4 different vehicles to do that. Or you need to wade through the boggy field, get into a boat, go across the river, clamber across the rocks, and then get something else with the sand dunes. Whereas with this, you can just fly over all of it, but you only need to be a foot above the ground to do it. So we minimize risk by just flying low and not flying too fast, really. So with a jet suit, you can just take off, glide over all of it. You don't need to change vehicle once and land at the other end.
And is that, I mean, I want to get more into the 3D printing, because we talked a bit about that, and you obviously focus on the design optimization of that. But also, is that, when we're saying about this, getting over terrains, different areas and mountains, is that a big driving force for this? Because that is, you know, being able to get to places that it's taking a long time to get to, emergency services, things like that. Is that a big part of the growing business?
Well, when Richard started this, it was for the thrill of the challenge, as he puts it. So what can you actually enable by giving the human brain, with its amazing balance capability, propulsion? Because if you were standing here now and I pushed you, you'd stumble and stay the right way up, and you wouldn't have even thought about it. You would have just stumbled, your legs would have gone in the right order and just kept you upright after stumbling. That is an amazing achievement of balance and control. So if you give that same system propulsion, now that you can fly, now possibly it opens up a whole new kind of capability of what a human can do. And it's what the people at Boston Dynamics building these amazing walking robots spend all of their time doing, is just trying to replicate what a human can do in terms of balance and control. So with the jet suit, it is simply augmenting the human brain and its amazing balance system with enough thrust to fly. So there was no aim of just like a specific niche or industry. It was just like, can you do it? And he went down the route of experimenting with engines on the arms, engines on the legs, different engine positions everywhere, different types of propulsion. And it got to the point where we have this arrangement now where it's 2 engines on each arm and 1 larger engine on the rear in a backpack. And that's the most stable kind of tripod of thrust arrangement. So after that, it's kind of become clear that there's lots of different niches that can actually benefit from this, and they kind of come to us because they see what we can do on social media. It's like some of what we were discussing earlier, where we do a lot of entertainment things, like we'll turn up to an event and do a demo flight because it's quite inspiring to see as a child, because when you see this live, you get the rumble of these engines. You really feel like a rocket launch in your chest as we fly up, and then obviously you've got a person hovering back at you. It's not like looking at a helicopter, just a metal carcass. You can see a person there hovering, smiling back at you, and then that person lands, stows the engines, and can shake your hand. So it's much more relatable. And so we do a lot of entertainment stuff, like social media on its own. We've got loads of clips on there that go viral often, which is not the aim of it. It's just kind of a fun aside. So there's the entertainment side of things. We were going to do a race series just before lockdown. We were going to be in Bermuda with 6 of us racing around pylons over water. So it means that if you crash and spin out, you just land in the water, steam gets thrown up. So that would be brilliant fun. Obviously, we've paused that because of the COVID situation until it's popular to bring people back together. But there's the entertainment side. We've obviously done much stuff with the special forces, flying from ship to ship, because normally when you move from one massive ship to another, you've got to get onto a little ship which has to berth with the big ship. You then move across and then you go to the other ship, and it takes many minutes, if not like 20 minutes, to get from one big ship to another. Whereas with this, as long as you can see the other ship, you just take off in the air, land, and you're done. And then the mountain rescue, again, you can fly up a mountain and stabilize someone, which is what we're exploring with the paramedics. There's loads of weird little niches that have come out the woodwork, which we're exploring at the moment. So those are just some of them, which has been brilliant fun, because that was never the original goal from Richard. They've just all come out of the woodwork as we've designed and productized the suit to a point where it's not a prototype. We're now working towards something that, like a DJI drone that you buy, it doesn't matter whether you're a pilot or not, you can turn on a little camera drone with my big sausage finger. I can press the button on the top, the thing will spring into life, take off, and now I can take amazing aerial shots of my house. I didn't have to know how to pilot it. I just point it where I want it to go. So doing the same with the jet suit, where it's just easy. You just put on this backpack, put your arms in here, press the go button, and then off you go. That's what we're working towards.
I'm sure there's going to be lots more people and opportunities and industries that are going to be like, can you do this? That's going to be exciting to watch progress for you guys. With the 3D printing, I mean, you talked about the benefits. Is that the cost, the customization, the adapt to the jet suit, the ease of production? Is that, you know, obviously you mentioned that it can be made in one piece. Talk to us a bit more about that, maybe.
Yeah, so people kind of varying knowledge levels of 3D printing, and you can get anything from a little consumer printer that you sit in your house and it prints little plastic bits like this. This is 3D printed. This is a phone holder. How exciting. But simple things like that you can print on a home-sized printer, and it just allows you to suddenly create three-dimensional objects to make products that never previously existed. And you can have that for a couple of £100 sitting in your house. I wish I had it when I was 12. When I was making rockets when I was 12, I was jigsawing pieces of oak shelf out to try and make them vaguely circular so I could make them use them as a little bulkhead in one of my model rockets. Whereas now I can just design it on the computer, press print, and 2 hours later it'll be sitting there. It's so cool. So it is just fantastic. But that goes all the way up to professional grade printers, which can print beautiful looking, really solid structural parts that are the size of a backpack. So because now we can make this custom shape without having to sit there and rivet it together, we can design something where we hit print, a couple of days later it arrives, and we can produce something that has an incredibly organic shape. It's not something that's limited by, can I get the hammer in here to nail this in or screw this in or bolt this in? And can a CNC cutter on a CNC machine get on the inside of an object? So imagine if you want to make a hollow object, you can't necessarily get your tooling on the inside to hollow it out. Whereas with 3D printing, you can just create pretty much any organic alien looking shape. So that's brilliant because it means we can have very thin, lightweight structures with air flowing through them. So the long and short of it is you can make these crazy looking, cool, lightweight structures if you 3D print them. So it makes sense that we design one, test it, and then all the little bits we don't like, we can just tweak in the design on the computer, then hit print again. And the new one comes with all the little design optimizations. And we can do that again and again and again without having to buy like a massive new injection molding tool every time we tweak the design. So that keeps us moving rapidly and iteratively improving the jet suit. And you can do that for both polymer, plastic 3D printing and metal stuff like these bits I'm showing you. These are metal 3D printed. This is titanium. This is an alloy called Inconel, which goes to very high temperatures. But all of this would normally be like 24 different parts, which you'd have to go in there and weld and bolt together. Yeah. Whereas this is just one, and you can print it all in one. So it makes your assembly life much easier.
And I mean, I'm already thinking I need to get my 12-year-old son something for that, like that. You're going to have
absolutely do.
So that sounds very exciting for a 12-year-old boy. But also you mentioned lightweight there. Now, being, as I mentioned to you earlier, a soapbox event organizer, we know that speed, you know, someone did something quite heavy one year, and without giving too many secrets away for the soapbox, light is better than heavy. Without giving away too many of your trade secrets, what materials are used in a jet suit to make it lightweight but robust?
We switched from nylon to, we did a lot with nylon early on, 3D printed nylon, and it's brilliant because it's very strong and robust. But you know those old rulers you'd get at school where you smack them against the surface and they shatter, even though they say they're shatter resistant. Nylon kind of does that when you surprise it with impact. So if you were to have an impact like that, even if you just whack it against the table, it just goes into loads of little bits, which is not great. So now most of what we do is printed in polypropylene. We've moved as far as we can away from metal printing because metal printing is a lot more expensive. So we just have that where it's needed in high temperature areas. But we move mostly to polypropylene printing now, because you can just bend it, and you can just bend it. What do I mean? I mean, it's a lot more impact resistant, so I can whack it against the table and it just takes the impact. It's more like on the way to being a car tire material, because we've always said the ideal material for the jet suit would be a car tire. You could throw that out the back of a plane at 30,000 feet, it would hit the ground, bounce, and still be a car tire. It wouldn't have broken. So that would be the ideal. So that's what polypropylene is like. It's a lot more kind of spongy and impact absorbing, more like kind of a human. So we want to have something that gels as closely as possible with a human and kind of morphs with them. So we've moved to a lot of polypropylene printing now. But I would say, going back to your point, is you should absolutely get your 12-year-old son a 3D printer. Like there's ones by I shouldn't be advertising, but I think the Creality Ender is really good or something. So just Amazon that, and you should get them that, because
I'm going to hit you up later on Insta. Definitely, I'm going to hit you up later, without doubt. But I mean, also you mentioned shattering rulers or throwing tires out of moving vehicles. What sort of tests do you have to alight on the perfect blend of metal and polymer? I mean, what are the sort of tests that you have to do?
It's mainly down to temperature. So anything that gets very hot needs to be metal, and anything that doesn't get quite as hot, this is the very technical explanation. Everything that doesn't get quite as hot, we just do plastic, because the plastic is cheaper to print and make and iterate. So everything that can be a lovely spongy thing that forms to the human, and if you did fall over it, the impact it just absorbs, that is better. So wherever it's high temperature, metal, which is not very much now. We've got this cool method of flowing air through the suit, so it keeps everything cooled down, and everything else is printed polymer, really.
And what happens at the Goodwood facility in Chichester? This is a design and production centre. Is that a venue for flight experience and flight training, a testing centre? What's happening there?
Yeah, that's flight training and flight experience. So that's where you'll go if you want to have a go at actually strapping it to you, feeling what it's like to experience the power of the jet suit. And then if you want to do more, then you can actually stay longer. Rather than just experiencing it, you can learn to fly with us, which depending on your experience and how good you are at it, it can be anywhere from like a few minutes to usually a few days or maybe a week it takes to get you flying. It just depends on the person, which is brilliant, because you get a completely varied set of how people approach learning to fly, because it's so human, it's so intuitive. It's I point the thrust where I point my arm. So that's great fun, and it's at Goodwood because one, it's quite noisy, and we're accompanied by AC Cobras whizzing around the track right by the training rig, and you've got chrome Spitfires taking off over the top of you. So it's a brilliant facility for it.
It sounds like a very boring job for you, Sam. Very dull and very boring and very, not fun at all remotely. I mean,
we're only talking about the glamorous bits. There's lots of time where we're sitting designing things and printing it and going, this doesn't work, does it? And then back to the drawing board.
But that as well is doing that, isn't it? As you said, when you're a young boy and you're having that experience of making something, and you have lots of mistakes before you get the right thing, and actually making something, creating it, and then seeing it in fruition is an amazing thing to do, to see that whole process through. What are other if people want to see a jet suit, maybe they'd like to do some flight training, they can come along and they can check that out. But where else do you see jet suits being used? I mean, we've mentioned search and rescue, paramedics. Are there any others that you think that personally you think it might be good for?
There's quite a few others that we're exploring at the moment that I don't think we're allowed to mention yet, but there's some really cool, just niche, crazy things that you never would have imagined. But the stuff I really like, and lots of the things that inspired me, were films, like anything from Chitty Chitty Bang Bang to how even the first Iron Man presented that first suit, when they do this amazing camera revolve around him as he's testing all these lovely deployable panels going in the first one. It's just fantastic, and things like Chitty Chitty Bang Bang have the amazing sense of theatre around the mechanics of an object and how it flies, but it's all about the kind of the journey you take it on and what you go and do with it. And because of that film side, that definitely did a lot of inspiring for me, I would love to do something like a Bond film or a Mission Impossible film, where even if we're just bad guys with black helmets and you never see the face or anything, but you're part of a chase scene, like down the Thames in London or something, to that lovely orchestral Bond swell would be brilliant. So I'd love to do a film or something.
That would be amazing. I mean, I remember seeing, as a very, very, giving away my age here, but as a very young child, seeing Peter Pan with Bonnie Langford in the London, one of the London theatres. But I mean, I imagine I saw Back to the Future recently, and they'd airlifted the car up, the DeLorean, which was just so impressive. But imagine maybe the things that you could do in the theatre. Or, I mean, you probably got a few restrictions there with people watching and spectators, but equally outdoors and things like that. I would imagine there's lots of opportunities there, isn't there?
Yeah, well, all of the events we do, like, there's no restrictions on how close you can get, really. Like, it's best to stand 5 meters away, but if you were stood right in front of me now, I could hover here, like with the thrust going either side of you. So, and that's when you get that great rumble. But you mentioned Back to the Future. That was one of my absolute favorites. So we did actually this. So this, I'm going to try and show you here if I manage to line it up. So this is flying alongside a real DeLorean.
Wow.
With the Back to the Future hoverboard velcroed to my boots. So we did this down at a runway in the south of England at sunset. And yeah, so that hoverboard is just velcroed to my boots. I'm flying the jet suit alongside the real car in this beautiful cinematic shot that we managed to get.
Amazing. I definitely need to talk to you about this soapbox. I have some ideas, a lot of ideas. How long would it take flight training, like hours, days, weeks? Like say for example, maybe I wanted to do something. How long would it? I mean, I know obviously it's person to person, but if someone wanted to come and experience that, is it? What's the process like? The time process?
Well, the best thing is to just do an experience where I think you do you do a few goes where you just get familiar with it, and like we'll do some demo flights, so you'll see what it's like to be flown and what you can do it with it when we really throw it around.
Yeah.
And then the experience is kind of the best part of it, really, where you actually put it on, you fire the thing up, and you get that lovely noise as it spools up, the sound, the flames leaking out the nozzles. You feel the thrust, you feel the power of this thing, and then you start to experience what it's like to have the thrust on your arms and doing your first kind of hops where it goes down to moon gravity. That's really the best thing to start with, and see if you like it. And then from there, if you feel like it, you can spend a few more days learning to actually control a hover and fly. Like I say, some people get it in a few goes. Some people it takes maybe a week to get to the point where they're doing a really nice stable hover and flying back and forth on the tether system. When you learn to fly with us, it's on a safety tether, so you have a tether behind you, which just means you can't fall over. So it's completely safe while you're actually learning and having a go and throwing it about.
And is there weather restrictions as well? I imagine, like, certain things can't be done in like high winds or rain or snow. I don't know.
We've actually flown in really high winds. It's quite cool because you just if that's flying normally, then if the wind's coming from this way at 40 miles an hour, you're just like that, but hovering in the same place. We're not affected by wind very much because we don't have a massive aerofoil or wing or anything like that, so we don't get blown about. We're a nice dense blob. And with rain and stuff, we can fly in most rain that you wouldn't mind being out in. When it gets really heavy, we'd probably stop, but it doesn't affect the engines really, ingesting water, same as a passenger jet. And we've flown in snow as well, so it doesn't really affect us. But you just want to when you come and train, you want it to be a pleasant day. So not raining is ideal.
Not raining is normally ideal, isn't it? It really is. And do you get, I mean, everyone loves a certificate. Do you get a certificate at the end of it? What do you then qualify to do once you've done your flight training? Do you guys, what would I become? What would I be?
Well, it depends how far you want to take it. You can come and join kind of a crew of pilots who are good and properly learning to fly and be part of the race series if you really want to take it further. Okay. But we have something better than a certificate. I'll keep that a secret though for the people who actually come and do it. But it's not like a boring piece of paper. Like I hate those. It's just a fake certificate and they've printed your name on it. It's much better than that.
I would like to think you could think of something a bit more imaginative than just a piece of paper certificate, I would think. But exactly. There's an opportunity you mentioned there about taking part in a team. There's an opportunity for jet suit pilots to take part in the international race. Can you tell us a bit more about that competition?
Yeah, so the race series is what I mentioned for Bermuda, and that'll be coming back live again when when we kind of deem it's acceptable to start doing that event again, which is looking like kind of soon. So yeah, the race series is where you have a load of guys and girls from different sporting backgrounds, and any background really, it doesn't have to be sporting, because it's amazing the group of people this has attracted over the last few years. They have, anything from helicopter pilots to gymnasts to Nobel Prize winners or whatever. It doesn't really matter. It's just all these people that have done amazing things that come and then apply this completely different backlog of previous experiences to learning to fly a jet suit. And so for the race series, it means everyone's got a different looking suit, like completely different color, pattern, outfit, whatever, and then you fly over water so that it's completely safe. If you do spin out or two people kind of bump into each other, you just go down into the water, so there's no danger. You just go into the water. We've got life jackets that automatically inflate. The suit is neutrally buoyant anyway, and you then sit there like a lemon in the water, floating while everyone else flies over you. And while people are flying, they're trying to get through these archways and obstacles and go up and over and round. So it's great fun to watch because you get the rumble as well as people fly past. It's like F1, you get that scream as they go past. This will be this rumble of 5 or 6 pilots tearing past you. And then obviously when they go down, it throws up loads of steam as the engines spool down into the water and stuff like that.
Amazing. And do people get to do like tricks like flips and things like that? Can you do all of that with your jet suit on?
We've kind of done one flip while we were doing some testing, but no one's really done like a free flight flip yet. We're starting to do some really fun like spins and things like that now. Now that we're kind of experimenting with it, but most of the flights we do will kind of roar in and then vector towards the audience, hover there for a second, spin around and go. So it's quite dynamic flying, but we've not done a loop-the-loop yet.
Oh, there's always time. There's always time. So are there plans to scale up the jet suit production for high volume, for commercial use? What will that involve? Fuel efficiency, lightweight, legislation for safe operation, I would imagine, those things. But
so we work very closely with the Civil Aviation Authority, and in terms of production, we're still on a journey of iterating it to be the best product it can possibly be. And it's not going to be like people are flying to work in these. They're very noisy, but it is something for that, especially close range mobility, especially with like the search and rescue paramedics, where you need to get up a mountain and help someone. There's a lot of other cool things like that actually help people that we're working on, and we need the suit to be an extremely robust product that you can rely on, that you just press the big red button and off you go, and it's reliable. It tells you, okay, you need to land now because you've gone your distance and you're low on fuel. It needs to make all of that really simple and easy. So that's our aim, and that's what we're continuing to develop, and suits that can lift payload and things like that.
So people, if they want to, before we're going to get to some questions, hopefully, from people asking some questions. If not, I've got some more for you, so don't worry. But is there anywhere people should be going to really find out more about you? You mentioned Insta and LinkedIn, because I'm sure there's lots of visual content that people would love to see. Yeah,
follow on Instagram and TikTok. It's at Take On Gravity, and for LinkedIn, it's Gravity Industries. And obviously, we've got a website, www.gravity.co. But Instagram and TikTok, you'll see the coolest stuff. So follow on there.
Amazing.
At Take On Gravity.
Amazing. Well, thank you for that great chat. I mean, that's fantastic.